So this is our second video on electrolysis, and this deals with quantitative electrolysis. The first video dealt with just figuring out the cell potential of electrolytic cell and who is going to be oxidized and reduced. So this type of question it involve all of these things which you can find on your equation sheet. So if you look on your equation sheet under the thermochem, electrochem, over on the right hand side, you'll notice a lot of things are defined. So I is current, given in amperes. You've probably heard of amps before, likely. And Q is charge. Charge is measured in coulombs. T is time, measured in seconds. A volt is a joule per coulomb. Faraday's constant is 96,485, and that's how many coulombs of charge there are in a mole of electrons. And N deals with moles of electrons, so think about how many moles of electrons are transferred in that oxidation reduction reaction that's occurring. And then the equation that's given, this would be over here on the left hand side, would be I equals Q over T. And I is the current, Q is charge, time. So current is charge over time. So again, these are all found on your equation sheets. It's a matter of knowing where to look for them and how you might apply them. So here's an example of a problem. If you're doing electrolysis, this is something that might be used in order to plate something. We'll talk about electroplating. Let's say you had some sample that you wanted to coat with silver. You can do that using electrolysis in a solution containing silver ions. And the reaction that would occur then is my silver ion is going to take an electron and form solid silver. So notice that during this reaction, 1 mole of electrons are being transferred. So let's take a look at the problem and figure out what we know and what we're trying to find. So we're trying to find amount of time. So this is how long would it take? We're given a mass and we're given a current in amps. So let's start out with my mass. Okay, so I know that I have 3.56 grams of silver. So what can I do with that? If I have mass and I know the identity of my substance, I can figure out moles. So I can look at the periodic table and say, well, I know that 1 mole of silver is 0.9 grams of silver. So that would tell me how many moles of silver I have. And if I look over here, it looks like these equations might involve moles of electrons. So I might want to take my moles of silver and say, well, look at this reaction that occurs. Every mole of silver that I want to make looks like it used up a mole of electrons. So I can use that ratio and say 1 mole of silver is going to, in order to make a mole of silver, I have to use a mole of electrons. Okay, so I've got grams there, moles of silver. If I stop and solve here, it'll tell me how many moles of electrons I would need in order to electroplate 3.56 grams of silver. I'm trying to find time though. So let's look at these relationships that I know. I have this relationship over here that tells me the charge per mole of electrons. So it's 96,000 coulombs per mole of electrons. So let's see if that'll be helpful. So every 1 mole of electrons will give me 96,485 coulombs of charge. So if I stop and solve now, I will have how many coulombs of charge it takes to make this many grams of silver. But again, the question's asking time. All right, so I want something that relates coulombs and time. So if I look over here, I've got this equation. The current is the charge per time, and the units are given right here. So what that means is, if I look back at the problem, it told me that it's 2.5 amps of current, and the current is the charge in coulombs over time in seconds. So 2.5 amps means there's 2.5 coulombs of charge traveling per every 1 second. So this gives a relationship from coulombs to time. So if right now I have an answer in coulombs, I can take this ratio and flip it over so that I have 2.5 coulombs for every 1 second. Now my coulombs cancel out. And if I stop and solve, this will tell me how many seconds it takes at this current to plate out 3.56 grams of silver. The question asked me, no, it didn't specify units, so I can leave it in seconds, or I could always convert this to minutes if I need to. So if you plug this into your calculator, you do it exactly as written. So 3.56 times 1 over 107 times 1 times 96,485. So take a moment, plug it into your calculator, see what you get. I'm going to stop and check my answer real quick. It should be if you convert it into minutes, it would be 21 minutes. So whatever times 60 that is would give you what it would be in seconds. So this is just one example of how you might do quantitative electrolysis. There's many variations of this that might involve amps, volts somehow, time, charge, masses, all varieties, but they all use these ideas right here, these equations and units that are given to you on your equation sheet. So remember, when you see a problem like this, look on your equation sheet and say, what can I apply in this situation?